Okay, welcome back. We'll take a look at Unit 11, Part 2, trig graphs, pages 5 through 6 for the lesson, and 7 and 8 on the homework. This time we'll be looking at vertical shifting of sinusoidal graphs. Now, sinusoidal sounds like sine, and it means sine, but it could also mean cosine. Sinusoidal is just kind of like another term for, like almost kind of like saying a trig graph, okay, but it's specific to being either sine or cosine. And that's the first thing we see here in the reading. Any graph primarily comprised of either the sine or cosine function is known as sinusoidal. These graphs can be stretched vertically. We saw that in the last lesson. That's what the value of A, the coefficient out front, affected, the amplitude. Other transformations can occur as well. Today we will explore graphs of the equations of the form y equals a sine of x plus c and y equals a cosine of x plus c. So here we saw that in the previous lesson. Now we are simply adding some value to the end of the equation. And what effect is that ultimately going to have? Well, it's going to have a vertical shift, okay, which is why we're talking about vertical shifts today, okay? So just like with polynomials, if we add something at the end of the equation, right, it goes up or down by whatever that value is, and that's what C affects here, okay? Since we already understand the effect of A, the amplitude, it is now time to review the effect of adding a constant. Consider the function f of x equals sine of x plus 3. How would the graph of sine of x be shifted to produce the graph of f of x? Well, we're literally taking this and adding 3. We're going to move it up 3 steps, right? We're translating it up. That's all these are, is our typical translations. Okay, so we're not multiplying anything here, we're just adding. So what was at 0, if I go up 3, is now up at 3. What was up at 1, if I add 3, is now up at 4. I'm literally taking each of these points and moving them up 3 steps. I'm taking the entire graph and moving it up 3 steps. And there we have the right-hand side. And carefully following suit, we can do the same with the left-hand side. Okay, so a vertical translation of the sine graph to get sine of x plus 3. Okay, other than that, it looks pretty much like the sine graph. Okay, it's going to keep going left and right forever if we let it. Okay. Okay, or vertical shift to answer the question. On the grid to the right, sketch the graph. We've already done that. Okay, so what did we do? We moved it up. Now, you heard me talk about this thing called the midline in the last lesson. Okay, well, in the last lesson, the midline, the line that cuts the top half and bottom half of the graph off, was always the x-axis. Okay, when we shifted this graph up, we essentially also moved the midline up 3. So this dotted line I'm putting in represents the midline. Okay, that's our midline. Separates the top half of the graph from the bottom half of the graph. Notice also that the amplitude here is 1. We do have a 1 in front of the sine function. So this graph still goes up 1 and down 1 from the midline. Okay, so that property is not affected. The amplitude still tells us we're going to go up and down 1. The plus 3 simply gave us where the new midline was. Okay, that was our new midline. The vertical shift. Okay, it's going to shift the midline up and down just like the rest of the graph. Number 2, consider y equals 2 cosine of x plus 1. On the calculator, sketch the graph to the right. Forget that. We don't want our calculators here. I'm going to put in the regular cosine function because ultimately we all got to know what this looks like. All right, this one starts up at 0, 1 and makes its way up and down like so. And going backwards, following the pattern. This is the regular cosine function. Okay, so again, you want to get used to that. Now what we're going to do is we're going to see what's going to happen to produce this. Okay, so we're doing 2 things algebraically to our original y values. Okay, our original y value is whatever this equals. And what are we doing to it? Well, here we're multiplying by 2, and then we're moving it, we're adding 1. Okay, so if we go through that algebra for each of these, right, let's take each y value, multiply by 2, and add 1 and see what this graph looks like. And then I'm going to talk about a different way to graph these, okay? As long as you know the basic sine and cosine graphs, these shouldn't be too bad at the end of the day, okay? But let's go through here. So starting at, let me pick up this color. Starting right here, okay, I'll go left to right. That's a y value of 1. That's this guy. 1 times 2 is 2, plus 1 is 3. So now we're up at 3. Okay, right now I'm starting at a y value of 0. 2 times 0 is 0, plus 1 is 1. So I'm up at 1. Okay, at negative pi, the original y value is negative 1. Negative 1 times 2 is negative 2. Plus 1 is negative 1. So guess what? I stay right where I was. Okay. Now I'm back to this point. The y value is 0. Times 2 is 0. Plus 1 is 1. And now I am at 0, comma 1. I take the y value of 1 and I multiply by 2. And I add 1. I'm up at 3. And so here's what one cycle of this is going to look like. When I take the original y values, multiply them by 2, and add 1. Okay? And now I'm just going to kind of repeat the pattern here. Once I have one cycle, I should be able to pick up the pattern. And here's the graph. Now, again, you could have used the calculator if you had to. Adjust the window, make sure you're in radian mode, all that good stuff. But this now is what the graph of y equals 2 cosine of x plus 1 would look like. Okay, let's talk about a couple things here, right? Where's the midline? Where's the line that cuts the top and bottom half of this graph off? Well, it looks to me like it's right here. Okay, and I'm focusing on the 2 cosine of x graph. Look, that separates the top and bottom half. From there, I go up 2, and I go down 2 off the midline, right? That's exactly what that amplitude out front tells us. So basically what you're going to start seeing me do is I'm going to start graphing these by first putting the midline in place. That's what that plus 1 is. That gives us the midline. The midline was up 1. From there, I go up and down by 2 because that's the amplitude. Okay. Give the equation of the horizontal line that this curve rises and falls 2 units above and below. That's our midline, okay? The equation of that line is that was up at y equals 1. That's our midline. And in the equation, that's C. C is our midline. When we write, y equals a cosine of x plus c. That's our midline. Okay, and the absolute value of A is the amplitude, how far up and down we go, and whether it's right side up or upside down. State the range of this function. Well, this time the graph went up to 3 and down to negative 1. So the range is negative 1, 3. Okay. Algebraically, what are we doing? Well, look, we can get that completely from the equation. Okay. Looking at the equation, okay, our midline was 1. That's the middle of the graph. From there, we're going to go up and down 2. So why not add 2 and subtract 2? If I start at a midline of 1 and I go up 2, I get up to a high value of 3. If I start at 1 and I go down 2, I get a low value of negative 1. So the range can be easily found by looking at your midline plus your A value and your midline minus your A value. That will always give you the range of these things algebraically. All right. For curves that have the general form, y equals a sine of x plus c, or y equals a cosine of x plus c, the value of c, as we just said, is called the midline, also known as its average value. Okay, its average value of the trig function. It is the height or horizontal line that the sinusoidal sine or cosine curve rises and falls above and below by a distance of the amplitude, the absolute value of a. Sketch and label the functions y equal 4 sine of x minus 2 and y equals negative 2 cosine of x plus 3 on the grid below. Try without the calculator. Okay, and then state the ranges. Okay, so here's how I go about graphing these. Okay. Look, the range, first of all, we can do like this. What's the midline? What's C? Negative 2. From there, we're going to go up and down 4. So plus 4, negative 2, minus 4. Negative 2 plus 4 is 2. Negative 2 minus is negative 6. So without even looking at the graph, I know this is going to lie between negative 6 and 2. Okay, but let's go ahead and now graph this thing. So again, here's how I'm going to do these. I start with my midline. The midline's down at negative 2. So I'm going to put a dotted line down there at y equals negative 2. Again, what do I know? I know that my basic sine curve looks like this. It goes through the origin. Okay, it goes up 1, down to negative 1. And these are like my basic quadrantals going up to 360 and back to 360, or pi over 2. It's those values. Okay, and so basically what I'm going to do is I'm going to take this, I'm going to shift it down 2. My midline's down 2, and from there, I'm going up and down by 4. So I've shifted my midline down 2, and now I'm taking the points on the regular sine curve, and I'm going up and down by 4. So basically, like, here's like the new start of the sine curve. At pi over 2, I'm usually at my high point. So at pi over 2, I'm going to go up 4 off my midline. 1, 2, 3, 4 off the midline puts me there. At pi, I'm back on my midline. At 3 pi over 2, the sine function hits its low point, which would be 4 below the midline, and then I'm back to the midline. This is how the sine function works. And now we get this graph. So I moved my midline in place, and then I used my amplitude of 4 and sketched in the basic shape of the sine curve over the midline. Okay, now going backwards, I can follow suit, and we've got 2 complete periods of the sine function here. 2 complete curves, 2 complete cycles. Okay. And sure enough, how high up did that go? Well, it went up to 2, and it indeed went down to negative 6, which we had before we even graphed this. All right, let's do the same for cosine now. The range, the midline is 3, so we're going to shift this up 3. And from there, we're going to go up and down 2. And it's going to be upside down. That's what the negative tells us. It's going to be upside down. Okay, but anyways, 3 plus negative 2, 3 minus negative 2 to get our range. 3 plus negative 2 is 1, 3 minus negative 2 is 5. The range will go from 1 to 5 then. Okay, low on the left side, high on the right side. All right, so again, to graph now, I'm going to start with my midline. That's up at 3. So dotted line at 3. And I'm going to take my basic cosine curve, which starts at the top like that, and I'm going to flip it upside down. And I got to go up and down by 2 this time. So instead of starting up at the top of the cosine, I'm going to flip it upside down. I'm going to go down 2 off my midline. So here's my midline at the origin. I go down 2. I know at pi over 2, I hit the midline. Then I'm going to be at my high point, back to my midline, back to my low point. And here is my upside down cosine curve. Okay, going backwards. Midline, high, midline, low. But again, to do this, you have to know your basic shape of regular sine and cosine. All right. And then all you're doing is drawing these either right side up or upside down over the appropriate midline and amplitude. Okay, so practice regular sine and cosine a little more if you know you need to, until you're able to do these, because these, shouldn't take too much more effort than what we're seeing right here now. Okay, but of course, if you have questions, let me know. All right, algebraic here, determine the range of each of these. So again, C, it's important that you do C plus A and C minus A, not A plus C and A minus C. That's not going to be the same thing. So again, range, C plus and minus A. So here we're going to do 4 plus 7, 4 minus 7. And the range here will go from -3 to 11. Next up, 2 plus -5, 2 minus -5, -3 and 7. And lastly, 35 plus 25, 35 minus 25. And it looks like 60 and 10, so 10 to 60 for that graph. And last but not least, the graph below shows a sinusoidal curve of the form y equals a sine of x plus c, so specifically a sine curve. Determine the values of a and c. Show how you arrive. Okay, well look, what I'm going to do is dot my midline in to begin here. And sure enough, there's the sine curve going through kind of the quote-unquote origin, if you will. It always goes through the midline if you consider that like your origin, whereas the cosine curve would start like up here and work its way down. Okay, so the sine curve always goes right through the midline at x equals 0 every time. So we definitely have a sine curve here. Now, a is the amplitude. Well, absolute value of a is the amplitude. That's how high and low off the midline we go. C is the midline, also known as the average value, they told us. Okay, so look, we have a couple y values given to us. The low y value is 6, and the high y value is 22, right? C is the average y value. So how are we going to find the average of low and high? We're going to add and divide by 2. So it looks like that midline is up at 14. Okay, so you take the average of high and low and you get your midline value 14. Now A is how high and low off the midline we go. If we now know that we're up at 14 here, what do we need to add or subtract to get to 22 or down to 6? And it's got to be the same thing or we messed up our midline. But let's see, if I do 22 minus 14, that equals 8. And if I do 14 minus 6, if I do these y values instead, that also equals 8. So that checks out. So amplitude is 8. Is A positive or negative is still the question. So there's like 3 things here. Let's get the value of C. We got that. Let's get the value of A once we have C. We got that. Now we just got to see if it's positive or negative. And again, this is where you need to know what the basic shape of sine looks like. Well, the basic sine curve as it comes out of, its little origin midline intersection there always starts by going up if it's right side up. So this graph does do that. It goes up and then down. That's a right side up sine curve. That means A is positive 8 here. Okay, so A was positive 8, C was 14. If we were asked to write the equation, we'd write y equals 8 sine of x plus 14. Okay, and sure enough, if we add these values, we get 22, which is our high. If we subtract, we get 6, which is our low. Everything checks out. Okay, take a look at the homework and then check these solutions out to make sure you can do these. Okay, let me know if you have questions, folks. Have a great day.